So, what actually happens when an application hits the big time and scales up? I mean, spinning up a single container, piece of cake. But what happens when that app suddenly outgrows it and you need dozens, hundreds, or literally thousands of containers all working together flawlessly without dropping connections or crashing? How do you keep the whole thing from just descending into absolute chaos? Welcome to The Explainer. Today, we are demystifying the whole concept of container orchestration. We're going to uncover exactly how modern, highly distributed applications manage to stay online, heal themselves, and update without you ever noticing. It's really all about this invisible conductor working behind the scenes. All right, let's dive into our roadmap for today. We'll start with why we actually need orchestrators, cover their core day-to-day tasks, look at security and introspection, compare the big platforms, and wrap up with some emerging trends. Part 1. The need for orchestrators. Because, let's be honest, managing a massive fleet of containers manually is practically impossible. Our source uses a really brilliant metaphor for this. Think of a single container running perfectly as a solo musician. It's beautiful, it works. But scale that up. Imagine an entire orchestra of talented musicians thrown into a room with complex sheet music, but completely left to their own devices. Without a conductor, it's just noise, total cacophony. Orchestrators act as that conductor, making sure all those different containers play together in absolute harmony. So, part 2, core orchestration tasks. What is this conductor actually doing all day? Well, the absolute most crucial thing to understand is reconciliation. You define a desired state, like, hey, I need 10 replicas of this service running. But the actual state is, reality. If a bug crashes a container and you suddenly drop to 9, the orchestrator spots that discrepancy immediately. It steps right in and spins up a new container to match your desired state. So basically, the orchestrator handles the tedious recovery work and you don't get paged at 3 a.m. And they give you different ways to deploy things. A replicated service just means you want a specific number of instances scattered somewhere in your cluster. But a global service is different. It guarantees exactly one instance runs on every single worker node. That is absolutely perfect for foundational stuff, like ensuring a security or monitoring agent is running everywhere. But here's a question. With all these containers rapidly spinning up and dying, how do they actually find each other? Well, this brings us to service discovery. And this brilliantly illustrates the concept. It's like the old days of telephony. Service A simply calls out for service B, and the orchestrator acts as the operator, dynamically patching that request through to an available, healthy instance. And that discovery process ties directly into intelligent routing. Think of it like a postal service. Step 1 is the internal post office, containers on the same node talking to each other, like coworkers in the same building. Step 2 is the neighboring building, routing traffic across entirely different nodes. And step 3 is the external postal service, handling outside traffic coming into your cluster. The orchestrator seamlessly routes all of it. Okay, but what about data? Containers are inherently ephemeral. They are literally born to die. If a container crashes, any temporary data it had just vanishes. So for critical data, like user databases, orchestrators use persistent storage. They completely decouple the data from the container. So if a pod dies, that critical data is totally safe and seamlessly reattaches to a fresh container. They also handle the holy grail of modern apps, zero downtime deployments. Let's look at a blue-green deployment. You roll out your shiny new green version right alongside the active blue version. You route some internal traffic to green to test it out. Once it looks solid, you just flip the main router over to green and decommission blue. And if something breaks, you just flip the router back. Nobody ever notices a thing. Part 3, security and introspection. Because obviously, a system doing all this heavy lifting needs to be locked down tight. Security here starts with trust. We can't just let any random node join the cluster, right? They use MTLS, Mutual Transport Layer Security. It automatically encrypts all the chatter between nodes and constantly rotates certificates to authenticate cryptographic identities. That keeps the management and control planes totally secure from bad actors trying to intercept data. Now, here is a truly wild and creative security concept from the source called reverse uptime. Imagine a hacker breaches a node and sets up a hidden base. With reverse uptime, the orchestrator is basically instructed to automatically drain, kill, and completely replace every node after a short period, say every 24 hours. The hacker's base literally just vanishes out from under them. But what happens when things break from a bug, not a hacker? We need visibility. Introspection turns the orchestrator from a black box into a glass box, and it's built on 3 pillars. Metrics show you system behavior over time. Logs give you the detailed event history. And traces let you follow a single user request bouncing between dozens of microservices, so you can pinpoint exactly where it failed. All right, part 4, popular orchestration platforms. Who are the actual players running these symphonies? Now, what's really interesting here is how these platforms cater to totally different needs. Kubernetes is obviously the heavyweight, the de facto standard for massive enterprise systems because it's endlessly extensible. But if you just want sheer simplicity and a tiny footprint, Docker Swarm still totally rocks. And if you have a mix of standard VMs alongside your containers, HashiCorp Nomad is a brilliant, incredibly lightweight option that manages everything from a single binary. Of course, for a lot of enterprises, actually running a Kubernetes control plane yourself is a massive headache. Enter Managed Cloud Orchestrators. Amazon EKS gives you that deep AWS security integration. Azure AKS hooks right into Entra ID. And Google GKE offers literal planetary scale, plus this amazing autopilot mode that essentially runs the whole show for you. These tools let your team actually focus on the app, not babysitting infrastructure. Part 5, Emerging Orchestration Trends. Because as powerful as all this is, the landscape is moving incredibly fast. The whole future is about removing friction. Think serverless containers where you never even have to think about underlying nodes, just run your code. Or GitOps, where your infrastructure updates automatically the second you make a Git commit. We're seeing edge computing push tiny clusters out to IoT devices, and even AI-driven scheduling that magically anticipates traffic spikes before they even happen. It's moving toward total automation.
If you want to dive deeper into the nuts and bolts of Kubernetes, GitOps, or setting up internal developer platforms, definitely scan the code provided here for a curated list of reading directly from our source material.
Which brings us to a final thought. With everything moving towards serverless setups, AI management, and these highly automated developer portals, is the ultimate destiny of orchestration to just become totally invisible? Will the developers of tomorrow even know what a cluster is? Or will they just write their code while a silent, autonomous conductor handles the rest? It's a pretty fascinating evolution. Thanks for tuning into this explainer, and we'll see you next time.